Hello everybody and welcome. I am the Shy Hat and we're going to be doing some PicoCTF 2024 challenges today. We are the HackerFrogs and we're going to be doing some beginners cybersecurity challenges. So this is going to be the last installment of going through PicoCTF challenges because I've come up to about the end of all the challenges that I completed during that particular event. But I hope we can have a lot of fun and maybe we'll learn a thing or two. Who knows? Alright, so let's start the night by doing this first challenge right here, which is called Endianness. So we can click on... So before we begin, I'm going to provide the link to the challenges that we're doing today. First of all, I'll provide the link to the particular set of challenges we're doing today, which is the PicoCTF 2024 event challenges. And then let's start with this challenge right here, which is called Endianness. So click on the general skills button right here. Just so everybody knows, if you want to solve these challenges, you have to first be logged into the PicoCTF website. Didn't mean to do that. Okay, so the Endianness challenge is a 200-point challenge in the general skills category. The description here says, know of little and big endian. Source code is here. Additional details will be available after launching your challenge instance. Okay, so we have a link over here that leads to a C source file. Alright, so what we're going to need to do to solve this challenge is we're going to need to go into our web shell. Okay, so in the web shell we're going to need to log in. Let me grab my login information, just a second. So I'm going to copy my password and I'm going to type in my username and I'm going to provide my password by pasting it in. And at that point, I'll be logged into my PicoCTF web shell. So let me full screen this. Okay, so inside the PicoCTF web shell, you have free reign over how you organize your files over here. I like to make a different directory for every challenge that I complete, so all the files are neat and organized. So the name of this challenge is Endianness. So I'm going to navigate to that directory, and in this directory right here we have a flag.c file which I downloaded earlier, but if you want to download it yourself, I will copy the link and I will provide it in the chat for everybody. But let's take a look at the contents of flag.c. I'm going to use nano to access that. So first of all, we're going to define a word. So what the gist of this challenge is that you need to translate the random word that is given to you by the program into the ASCII hex equivalent of the word. So the program is going to give you a word in ASCII, and you need to transform those characters, those ASCII characters, into the hex equivalent of those characters. So if you want to know what we're talking about, let's look it up real quickly over here. So it's ASCII hex chart. Okay, so let's just take a look at this image right here. So every character inside of ASCII. So let's take a look at some of the ASCII characters that are familiar here. So we have capital A, capital B. They each have a decimal code, which in this case is 65 for capital A and 66 for capital B. And they also have a hex code, which is 41 for capital A and 42 for capital B. What we need to do is we need to translate the characters that are sent by the server and turn them into their hex equivalents and send those to the server. All right. So not only that, but we have to send a little endian and a big endian version of each one of these words. Little endian order is where the order of the bytes is sent from the end of the string to the beginning of the string, which is basically reversed. And big endian is where the bytes are sent from the beginning of the string to the end of the string, which is what most people consider to be the normal order. Okay, so if we go back to the challenge over here, additional details will be available after launching your challenge instance. So this challenge right here is associated with a virtual machine, and you can start your virtual machine by clicking on the launch instance button over here. So let's do that. So the great thing about the virtual machines associated with the PicoCTF challenges is that they initialize very quickly. And normally you'll have between 30 minutes and 15 minutes to complete the challenge. So after we've started our virtual machine, we have a netcat command over here, which lets us interact with the challenge. So this is going to let us contact this server over here on this particular port, and that's going to let us access the challenge. We can copy this command right here, then go over to our web shell. So I'm going to get out of Nano here by using the Control X keyboard shortcut, and that gets me out of there. So I can paste in my, my command over here. So remember, when you're using Linux, the Linux console, you have to use Control-Shift-V instead of the regular Control-V to paste content into the terminal. So after we connect to the server by using this command right here, you will need to find both the little endian and big endian representations of a word. If you get both correct, you will see the flag. Okay, we've got a word right here, so it's not really a word, more like a random set of letters. So first we have to enter the little endian representation. So what we might do is we might go over to our ASCII chart and look up the small m and then the small q. So if we go to the ASCII chart, small m is 6D and small q is 71. So 6D 71, 6D 71. Oh wait, that's not how we would do it in Little Endian. Okay, all right. So I'm going to get out of here because there's a timeout for this. Okay, so it's UBAQU. So actually, there's a more convenient website to try to translate these ASCII letters to the hex equivalent, and that's going to be, we'll just look at ASCII, so hex to ASCII. So there's a hex to ASCII text string converter utility on this webpage right here, and we want to go from text to hexadecimal. Okay, so what we would do is we would go back to our web shell and we would copy the word over here, and it's going to automatically cut this for us, which is great. And then we go back to our ASCII to text website right here. We paste this in, and then we click on the green convert button. And it's going to feed us, it's going to give us this hex code right here for these characters. But the thing is that we need to enter them in reverse order because we're dealing with little endian order. So little endian means reverse order, so it's 75, 71, 61. 75, 71, 61. 75, 60, what was that again? 71, 61, okay. 71, and then 61, and there was a couple more, 6275. Okay, and then we do 62 and then 75. Okay, and then it says correct little endian representation, and it says enter the big endian representation. We would do the opposite of that, so that would be 75, 62, 61, 71, 75. Okay, and this should get us the flag. Okay, so we took the word over here, and then we translated these ASCII characters into the hex version over here on this website. But in the first instance, we entered it in little endian order, where the bytes go from the last byte to the first byte, and then we reverse that for the next question, which is big endian representation. Okay, and the flag, so the flag is this. We can copy this, and then we can go to the challenge page, and we can paste it into the flag submission field right here. Submit flag. Okay, you successfully answered the question again. Okay, so, and we can also click on the thumbs up button right here to rate this as positive, which would show appreciation for the challenge makers. So I'm going to demonstrate completing this challenge one more time, but this time we're going to use a Python script to automate the solving of this challenge. Okay, so what I need to do is copy this port number over here. So I've created a script which accesses the server and solves the challenge for us, and it's located at the HackerFrogs GitHub over here, and I'll provide the link in the chat for everybody if you want to try using this script yourself. So let me make this bigger so you can see what's going on. So the first thing that the script does is it imports the socket module from Python, and then we have to define a couple of functions. The first function is going to use the functions inside the socket module to connect to the host on a specific port number, and then we're going to use the socket functions and methods to connect to the server on a specific host and a specific port, and then we're going to send the little endian ASCII hex code of whatever word we received, and then we're going to send the big endian ASCII hex code of what we received, and then we receive the response. Maybe I should have used this one first. I should have demonstrated this function first, which is get word from server. So the first thing we do is we connect to the server on a particular host and a particular port, and then we define the socket, and then we get the response from the server, which is going to include the ASCII word. And then we're going to scan the response for the ASCII word, and for each character inside the ASCII word, we're going to define that as the variable the word, and the word is whatever we got from the server, and then we would send the send word to server with the hex equivalent of whatever the word is in little endian order first, and then big endian order. So let's demonstrate using this script in the web shell. Okay, so I've got the script over here. It's hexword.py. I'm going to nano into it. And first so the host is going to remain the same, but the port number is going to change. So we can go back to the challenge, and we can copy the port number, and we can go back to the editor over here, and we need to change the port number on both of these functions over here. So send word to server and get word from server. We need to change the port numbers on both of these. And then we're going to exit with Control X, save modified buffer Y, and then enter. So now we should be able to solve the challenge using the Python script. We just need to run python hexword.py here. And we see that it works. We received a word, which is this, and then we sent the It seems like I need to edit my script again. Hold on. Okay, so I changed the port number here. Let me take a look at this port number one more time. Okay, so 61093 and 61093, so this is correct. I just need to make sure that it's the same in the get word from server over here, so that's... I wonder what's wrong. Enter the little endian representation. So, did I... Okay, so we're going to received word, and then we should send the word to the server and receive the response, which is this. Okay, let me I'm going to do a little bit of, let's ask ChatGPT if it sees anything wrong with the code. Just a second. Okay, so we're going to copy this to ChatGPT and ask it if it sees anything wrong. Okay, I think I didn't copy this correctly. Let me do this again. Okay. So it doesn't see any particular errors with this code. I wonder... For some reason, it isn't really going through. It does send the little endian representation here, but for some reason the big endian representation doesn't get sent, which is strange because this was working. I'm going to have to look through this a little bit later. All right, so we're going to move on to the next challenge then, and this is the Mob Psycho challenge. Okay, so let's go back to the PicoCTF webpage and let's go to Mob Psycho, and I do believe it is on the next page, page 3, and here it is. Okay. So Mob Psycho is a 200-point forensics challenge, and the description here says, can you handle APKs? Download the Android APK here, and there's a link. So I'm going to provide the link to this challenge right here and link it in chat to anybody, so anybody who wants to try can try it out. And then I'm going to copy the link that leads to the APK package, and I will also link that in the chat. So we're going to go to our web shell, and we're going to move into the Mob Psycho directory, and I'm going to create a temporary directory to work in. And then I'm going to download the APK file over here. So with the wget command. So I've saved it. So the hint in the challenge over here says, did you know you can unzip APK files? Okay, so APK files are Android application files, which are used to install apps. So you can, according to this information right here, you can unzip them like you would any other compressed file. And you can do so with the following command right here. So it's going to be unzip and then mobpsycho.apk. So we do that. And it inflates and extracts all of these files over here that are associated with this Android program. Okay, so the challenge in this case is that we're supposed to find the flag inside of this file, and because this is a digital forensics category, we're expected to search through these files over here to find the flag, which is our objective. Well, the problem is that there are multiple directories, and each one of these directories there could be a few dozen files, so it's a bit difficult to manually search through them all. So what we're going to do is we're going to take the second hint from this challenge right here that says, now you have a whole host of shell tools for searching these files. Okay, so the first shell tool we could try when we're trying to locate a specific file is the find command. So it's going to be find and then specify the directory, which is the current directory and all of the other directories inside of this directory. So that is designated by the dot right here. And what we need to do is we need to search for a file name. And for example, we could look for something called a flag. So sometimes in these forensics challenges, we're looking for something called a flag file. So we could do star flag star, which means that we're looking for any file with a name that contains the string flag inside of it. So we can search for that, and it's going to find this file right here called flag.txt. Another thing we could do is we could look for strings inside of the files in here. For example, we could use the grep command. Let me pull up my notes real quick. Okay, so let me grab my grep command right here. So grep is going to search inside of files. So we use grep with the -r flag right here, which makes it recursive, which means that we can search inside of all the files in the current directory and in any inside of directories inside of this directory as well. And we can search for a particular string. I think it's with the -e command, and we can search for the string pico. And why would we search for the string pico? It's because most of the flags in PicoCTF start with the prefix. They start with the prefix PicoCTF. So we could actually just specify we're looking for PicoCTF as a prefix. When we run grep, Okay, and it's not going to find anything. But in a lot of cases, in these kind of files, they like to obscure the flag using either hexadecimal representation of ASCII, or they use base 64 to encode their flag. So we could try looking for something that's a grep command that's going to find hex digits, like long strings of hex digits. So I'm going to demonstrate this particular grep command right here. And we've got grep and then -r for recursive and then P for -P. I think this is going to let us do, let me ask real quick what the -P, when using grep, what does the -P flag do? Okay, so the -E flag enables Perl compatible regular expressions. Okay, so we're sending a big regular expression along with this command here, and in this case, it's going to look for these particular characters. So the numbers 0 to 9, the letters A to F, and the capital letters A to F. And these are this is the character set that they use inside of hex code. And the last thing right here denotes that it's going to search in the current directory. So we do that, and we see that this matches right here, which is the flag.txt file inside of .res /res/color. So what we need to do is we need to look inside of this directory. So we're going to cat out that particular file. And it's just this right here. So because this is a long string of hexadecimal characters, this might be the hexadecimal representation of ASCII. So we covered the difference between ASCII and the hex representation in the last challenge, but let's copy this over, and we can check this with the app we were using in the last challenge, which is the ASCII text to hex code converter. Okay, but in this case, we're going to go from hexadecimal to text. So we're going to paste in our long hex string, and then we're going to hit the convert button over here, and it's going to give us the flag. Okay, so we can copy the flag, and then we can go back to the challenge page and paste in the flag in the challenge submission panel right here. So click on Submit Flag, and then we can go back to the challenge and we can upvote it to show our appreciation for this challenge to the challenge maker. Okay, great. Okay, so let's move on to the next challenge. So the next challenge is a more difficult challenge. It is the challenge called Heap 2. So we already went through Heap 0 and Heap 1 in previous installments of the PicoCTF 2024 walkthrough, but let's look at Heap 2. So I'm going to copy the URL for this challenge and paste it in the chat. And now let's take a look at this challenge description. So it's Heap 2, it's a binary exploitation challenge. So it says here, can you handle function pointers? Download the binary here, download the source here. Additional details will be available after launching your challenge instance. Okay, so we've got two links over here, one for the binary that we're going to be dealing with and one for the source code. I will include links for both of those in the chat. Okay, so now let's go to our web shell and let's navigate to the directory over here. So it's going to be heap2. So there's no such file or directory. Let's, oh, hold on. Okay, so I've got the challenge binary here, and I've got the source file right here, which I've renamed to source.c. So when you download the challenge file right here, chal, C-H-A-L-L, you'll find that it is not executable. So what you need to do is you need to run the following command to make it executable. So chmod +x and then chall, C-H-A-L-L, and that's going to make the file executable. Okay, so let's take a look at the source file right here. So source.c, well, for you it's going to be chal.c, but I'm going to use the nano text editor. Okay, so we've defined a flag size max buffer over here as 64, so that means that there are 64 bytes allocated to this particular buffer. Okay, memory buffer. Okay, so immediately here we see that there's a win function right here that prints out the flag. So it's going to take the number of characters in the buffer, flag size max, and it's going to open the flag.txt file and read it, and then it's going to print it, and then it's going to flush and then exit. Okay, so what we need to do is we need to find a way to activate this function inside of the program. Okay, so here, so I think it's easier to demonstrate this by running the program. So I'm going to get out of here, and we're going to run the chal. Actually, what I need to do is I need to create a flag file inside of this program here. So not inside the program, but I just need to create a flag to be accessed inside this file. So I'm going to echo, we got the flag, and I'm going to redirect this into flag.txt. So if for some reason we're able to compromise the program and get it to run the win function, then it's going to print out the contents of the flag right here. Okay, so let's try running the program. So the function, I sometimes like to call it, maybe you should change it. Okay, so we can print out the contents of the heap. And we have our, as in the previous challenges, we've got our Pico and Bico values over here. And this time, we're not trying to change the value of Bico over here to Pico like we did in the last challenge. But what we need to do is we need to point the Bico memory space over here to the win function. So how do we do that? Let's take a look at what we have inside the program first. Okay, so we can print x, and x is equal to Bico. But what we want to do is we want to change this to the memory location where the win function is located. So in order to do that, I'm going to use the R2, the Radare 2 binary exploitation framework in order to do so. So I'm going to exit out of here first. So what I need to do is, let me grab my notes. Binary exploitation, and this is heap 2. Okay, so we're going to use Radare 2 to analyze this binary file here. So it's going to be chal. So what we need to do is we're going to use the Robin2 function. Sorry, Robin2 program, and we're going to take a look at this program right here. It's Robin2 is going to give us a bunch of information about this program. So it's got a lot of different information about this program. So the architecture is x86, and it's a ELF binary. and it's a 64-bit binary. But what we need to take note of right here is that this program goes in little endian order. So we talked about little endian in the first challenge we were talking about, what we solved in today's session. But little endian basically means that the bytes go in from the end of the string first and then goes to the beginning of the string. It basically means that we have to enter the bytes in reverse order whenever we're dealing with this program. Okay, so that's what we get from the Robin 2 program. Next, we're going to use Radare2, the main Radare2 program, R2, and then -D for debug, and /A for analyze. And then we're going to specify the file, which is the chow file right here. Let me take a little drink. Okay, so we're going to run the program. And the Radare2 program has analyzed all the flags and all the functions. So this is very, very convenient for us. So next we're going to print out the information about the functions. And in Radare2, it's the AFL command. So we run that. And then it gives us the memory location of all of these different functions within the program. Okay, and I think what we're looking for is this function right here, which is check win. No, we're not. We're looking for sim win, right? So the win function right here. So it's at this particular memory address right here. We're going to have to take a note of that, but the thing is that because we're dealing with little endian order, byte order, we have to take note of this memory address in reverse order. So it'd be AO, the last two bytes right here, and then 11, and then 40. So it's an opposite order, but we're going by twos. Okay, so I'm going to take note of that. Just a second. So it's A0 and then 11 and then 40. Okay, great. Okay, so next we're going to exit. Do we want to quit? Yes. Do we want to quit the process? Yes. Okay, so next we're going to send we're going to use a Python command to send different bytes to the program. So the bytes that we're going to send are going to do a bunch of different things in the program. So let me pull up the program first. So the first thing we're going to do is we're going to select the write to buffer. So we're going to write to buffer, and then we're going to write the bytes that include the address of the win function. But not only that, we're going to fill the buffer first. In which case we need to fill the buffer with 32 bytes of information. Because that's going to let us overflow the buffer. And then we're going to include the memory address of the win function, and then we're going to use the print flag function over here. So let's get into this program first. And then I'm going to show you the Python command we're going to use. So Python C for command, we're going to import the sys function for the system function, and then system standard out buffer right, and then these bytes over here. So it's going to be, we're going to select write to buffer with this command, with these bytes right here, and then we're going to select the bytes. So it's a bunch of A's, 32 of them, and then we're going to send the bytes that include the memory address of the win function over here, and then we're going to select enter, and then we're going to select print out the flag, that particular print flag, which is this one right here, and these are all the bytes that correspond with that. So when we run this command, it's going to pipe all of this into the challenge binary over here, and so it brings up the output over here of the program, and then we got the flag, which is the content of the flag file that we specified in when we created this file inside this directory. Okay, so next what we need to do is we need to do the same thing, but we need to access the this version of the program that's running in the server. So to do that, we need to go over to PicoCTF, and we need to launch the instance over here. So after that's done, it gives us the command to access the program on the server, which is this server right here on this port. So I'm going to copy this, then go back to the web shell, and then we're going to bring back the command we used previously, and then we're going to paste in the server and the port where we can access this program. It's going to access the server, and then it's going to pipe in this Python command right here, and then we should get the flag after we've run this command. So we run the command. So it accesses the program in the server there, which has the actual flag, and then we overwrote the buffer and supplied the address of the win function, and that got us the flag, which is this right here. So you can copy the flag and then go to the challenge description page and paste in the flag and click on submit. Okay, so before we finish, let's go over to the challenge again, and if you haven't done so, please rate positive this challenge right here with the thumbs up button. Okay. Alright, so before we move on to the next challenge, I'm going to point out where you can get my notes for this particular challenge. Let me grab this link over here. So this is the Heap 2 notes right here. So I'm going to also provide this particular file on GitHub and paste it in the chat so you can access it if you like. Okay. All right, so we're going to move on to the last challenge we're going to be doing tonight, and that is the Don't You Love Banners challenge. Okay, so I'm going to get back out of here. So let's access this challenge. It's going to be on the last page of the challenges here. So Don't You Love Banners? So this is the last challenge in the general skills category, and I'll provide the link to the challenge in the chat. Okay, so Don't You Love Banners? General skills. Can you abuse the banner? Additional details will be made available after launching your challenge instance. Okay, so we don't necessarily have to create a directory for this particular challenge. We just need to launch the instance. Okay, so after it's done, it says here, the server has been leaking some crucial information on this server right here at this port. Use the leaked information to get to the server. To connect to the running application, use NC netcat, and then this server right here on this particular port. From the above information, abuse the machine and find the flag in the /root directory. Okay. So what we need to do is we need to get the crucial information that's been leaked from this particular server right here on this port. So we can copy that. And then we can go to the web shell. Okay, so we're going to paste in the server and the port, and then we're going to netcat to that particular port. What it says in the banner over here is my password 1234. So this is obviously some information that we shouldn't be getting, but it's been leaked by this particular banner. So this is an example of a banner. A banner is something that a network service displays after it's been connected to. So in this case, we have this password right here. So we can copy it, and then we can get out of here by using the Control-C keyboard shortcut to cancel out of this program. And we can keep this password somewhere. I'm just going to put it in my notepad for now. And then to connect to the running application, use this command right here, so you can copy that. And then in the web shell, access it. And it says, so the banner over here says, welcome. What is the password? So we know that the password is this. We can copy it, and then we can paste it in. And then we have another question over here. What is the top cybersecurity conference in the world? So to anybody who knows, the answer is DEF CON, which is the cybersecurity convention that happens every year, and it's been happening in Las Vegas for the last 20 years, 30 years. It's been a while. Okay, so supply that as the answer. And the next question is, the first hacker ever was known for phreaking, making free phone calls. Who was it? Okay, so this is a bit of hacker trivia, and the answer is John Draper. So John Draper was this famous hacker who was able to make free phone calls by phreaking, which is basically whistling or sending particular notes into the telephone. And I'm not exactly sure the nitty-gritty details of phreaking, but it's basically submitting specific tones into a telephone to get access to free phone calls. This was really popular in the past when people used a lot of pay phones, but I'm not sure if it works anymore. Okay, so that's the answer, John Draper. And now we're in. So we're at player at challenge. So our username is player. We're on the challenge server right here. If we ls to take a look at what's in this directory right here, it's banner and text. Let's take a look with a little more detail by using the ls with the LA flags. Okay, and so we see that inside of here, we are the player, so we own these files. Strangely, we own the banner file over here. We have read and write. No. Yeah, so we read and write privileges on this particular file. And we also have this text file right here that is owned by root. So if we read the banner, this is the welcome banner we saw when we logged into the system. Okay, and there's also the text file. It says keep digging. Okay, so let me grab my notes. Okay, so if you remember the hint from the challenge description, it said that the flag file was in the root directory. So normally we're not able to read the root directory, but for some reason we can read the root directory on this server right here. So there's two files in the root directory. There's one called flag.txt, which is the goal for this particular challenge, and there's a script.py file. Okay, so let's take a look with a little more detail with ls-la. So the interesting thing is that this file, this folder, this directory is readable by anybody, and anybody can execute stuff in this directory, which is a bit unusual. But we also see that the flag.txt file is not readable by anybody, so that's unfortunate. But we see the script.py file over here is readable. So what we need to do is we need to read this file. So we're going to cat it out. Okay, so this is a Python script. So it uses both the OS and the PTY modules. And the first thing we see over here is something very suspicious. So it's try with open, okay, and this is home player / banner. So this is the file that is in our current directory. So read this. So print f.read. And if the file doesn't exist, it's going to print out this default banner right here. And it seems that this file is basically what is letting us log into the system. So this is the script that logs us into the system. It asks for the password, it asks for the top cybersecurity conference in the world, and it asks for the first hacker that was known for phreaking. Okay, so the thing is, the interesting thing about this file is that this is run each time we log in. But it also uses this file right here, the banner file, and we have control over the banner file. So we see here that the banner file is owned by us, the player, and it is accessed each time we log in. So what we can do is we can take advantage of this by creating a symbolic link, which is basically a link is something that points to another file, and we can make this banner file point to the flag file. And after we've made a symbolic link from the banner file to the flag file, the next time we log in, instead of the banner, the contents of the flag file will be displayed. Okay? So the first thing we need to do to pull off this plan is to remove the banner file. So rm banner, and then the banner doesn't exist anymore. Next, we're going to create a symbolic link. So we can do that with the ln command. So link-s for symbolic, and then we're going to specify the file that is linked to, which is /root/flag.txt. And then we're going to name the file banner. So that creates a file called banner, which is actually a symbolic link to /root/flag.txt. Okay, so that means that when we log in, the Python script in the root directory is going to run, and instead of the banner that we saw in the when we first logged in that said welcome, it's going to give us the flag. So we can test this out by exiting out of the server, exit, and then we can log in one more time. So when we log in, we're not going to need to supply a password because the flag is going to be printed out for us immediately. Okay, so we try logging in, and because we replace the banner with a symbolic link that goes to flag.txt, we get the contents of flag.txt right here. So we can copy this. and then go back to the challenge description page, paste in the flag, and submit the flag. So don't forget to click on the rate positive button right here to show appreciation to the challenge makers. Okay, so that is the last challenge we're doing for tonight that has to do with PicoCTF, but I hope you all enjoyed that portion of the stream. Next, we're going to do some over the wire CTF challenges, specifically the Natas series of challenges, web app hacking challenges, and we're going to solve them by using Burp Suite. So I'm going to be using Burp Suite, and Burp Suite can be accessed inside of Kali Linux by going up to the programs button over here, and we can type in burp, and Burp Suite should appear over here. Click on that, and then we can run Burp Suite from over here. So inside of Community Edition, we have to click on Next to get to, and then start Burp. Okay, so Burp Suite can be quite intimidating for people who are new to the program, but it is a very powerful web app hacking platform. So platform? No, it's a framework. It's a web app hacking framework that includes several different tools. So the first thing we want to do is we want to go to the proxy tab over here, and we want to make sure that intercept is off. It is off by default on this version of Burp, but on other versions of Burp Suite, intercept is not off by default, and you're going to have a bad time if it is off when you want it to be on, or if it's on when you want it to be off. So make sure it's off, and then we're going to open up the Burp browser. So we can click on this button right here, which is labeled Open Browser. And the great thing about the Burp browser is that it is connected to Burp Suite, which means that any traffic that we see inside of this browser is going to be sent to Burp Suite by default. So we're going to look up the Natas CTF. So over the wire Natas, we're going to search for that. So the Natas CTF teaches the basics of server-side web security. Okay, so this is a CTF that I use extensively when I was teaching my HackerFrogs web app hacking course. So, but this time we're going to be solving the challenges using Burp. Okay, so Burp Suite rather. So we're going to copy this URL and paste it into the web browser. Okay, so we're going to have to supply a username and a password. So username is Natas, and then username is Natas0, and the password is Natas0. Okay, click on Sign In. Okay, so after we've accessed the page, we can go back to Burp Suite. So I'm going to minimize the browser. We can go to this tab right here, which is called HTTP History. So we can click on that, and we see that all of the web traffic, all of the web requests that we sent inside of the Burp browser are all here. Okay, so I wish I could make this a little bit bigger for you guys, but what we're going to do is we're going to click on the number column right here, and we see here this particular request right here, which is associated with logging into the Natas 0 webpage. Okay, so this is the request portion of the request, and this was the server response right here. So the great thing about this response right here is that we can actually click on this tab right here, which is Render View, and that's going to give us the web browser view of this particular web page. So it's going to take a little bit because it's trying to render out the response that we received from the server. So it's taking a little longer than usual. But we actually don't need to take a look at this. What we want to do is we want to look at the it seems like Burp Suite has. I was going to say that it seems like Burp Suite has crashed, but it does seem to be using a lot of system resources, as indicated over here. Okay, so in the response over here, it says you can find the password for the next level on this page, and then there's a comment right here that says that the password for Natas 1 is this right here. So this is the flag for the level, and it seems like I can't highlight any of this. That's strange. It might be because the system resources are all being taken up. What I'm going to do is I'm going to close out Burp Suite and I'm going to try opening it again. Sorry about the delay, everyone. Okay, so Burp seems to have frozen my system right here, so that's unfortunate. What I'm going to do is I'm going to so even if it hadn't, it seems that my virtual machine is going a bit haywire right now. So I'm going to close this out. I'm going to power off the machine, and I'm going to reboot my virtual machine. Okay, and then I'm going to restart the virtual machine. So if you haven't used virtual machines with either VirtualBox or what is the other one called? It's called VMware. So if you've ever used virtual machines with VirtualBox or VMware, I highly recommend doing so because it allows you to study cybersecurity without using your own personal computer, which is great when you're trying to do stuff like play around with the security tools. And it also lets you access different OSs. SnowXCone rating with a party of 30. Welcome everybody from SnowXCone's stream. I hope you guys had a lot of fun over there doing co-working. I'm sorry you guys are getting timed out by the bot. It's okay. You guys will be okay. Derek Snow says, so we're learning how to get people's CC info. Thank you for following Volko. Snowflakes are following the chat. What we're doing is we're going to be using a particular program to try to intercept web traffic. Okay, so Chebby, hello. LW Killer, hello. Chebby, thank you for following. Hackermans says, SnowXCone, thank you very much. So I didn't expect this. I was just going about my merry way, doing my web app hacking demonstration over here. So we're using a program called Burp Suite, and Burp Suite is a program which we can use to test out to test out web app applications. So, oh my gosh, something's... Okay, glad to see you streaming now. Well, thank you very much, Volko. Yeah, I know most of the chatters from SnowXCone's chat. I'm often in her chat. So we're taking a look at Burp Suite Community Edition, which is the free version. Poor Eye says, "What up? What up to you guys?" All right, so inside of Burp, we can intercept and record all of the traffic from web traffic from a particular web browser. What we do is we go over to our proxy tab over here, and then we click on Open Browser, which is going to burp burp burp. Says SnowXCone. Thank you very much. Volko says, "Gotta love burping." Yup, all about that life. Thank you for following Blizzard WQ. It's very thanks for coming by, everybody. So Chromium didn't close proper. I'm going to restore this. So wow, you gassy, says Derek Snow. Okay, great. Rose Sebastian, thank you for following. You're now a HackerFrog. All right, so what we're doing is we're going over a particular what was it, CTF challenge. So these are CTF challenges that are all associated with web app hacking. So I'm going to paste the address of the challenge that we're going through right now. It's natas0.nataslabs@overthewire.org. So I'm going to demonstrate over here in my web browser what happens if you go to this particular URL. So it's going to ask you for a username and a password. So what you need to do is you need to give it the username Natas0, and you need to give it the password Natas0. So Natas0 is the username, Natas0 is the password, and then you click sign in. Okay, so you can find the password for the next level on this page. So if anybody knows, how can you try inspecting this web page to see if there's anything suspicious going on? Does anybody know? Okay, Volko says it's Control plus U. Okay, so you can do Control U, or you can also click on this. You can right click and then click on this selection right here, which is View Page Source. Polarized also says Inspect Element and Network. Okay, so all right. So each time you access one of these web pages inside of this CTF game, you have to get the password for the next level, and the password for the next level can be obtained by doing some sort of web app application trick. So, for example, this is the password for the next level right here, and it's inside of one of these HTTP comments. So I'm going to copy this and provide it to the chat. Okay. So yeah. I'll help you all try to go through a couple of levels of this particular game, and you might learn a thing or two about web applications, which is basically a fancy way of saying like websites and stuff in the internet. Okay, so now that we have the password for the next level, we can try to access the next level by going over to the URL address bar, and we'll replace Natas0 in there with Natas1. So navigate to that web page, and it'll ask you for a username and a password. Okay, so the username is going to be Natas1, and the password is going to be the password you obtained in the last level, which was this right here, or this over here. LW Killer says they can encrypt the password. No? Well, I mean, the first couple of levels of this game are made as easy as possible, but they get harder as you go on. So Natas1 is the username, and the password is this. We're going to click on sign in. Okay, so it says you can find the password for the next level on this page, but right-clicking has been blocked. So, of course, it's bugged in Firefox. So inside of Chrome, or in Chrome or some other web browsers, you're not allowed to right-click. But for some reason, inside of Firefox, you can. Okay, so if you're using Chrome, you might not be able to right-click. It'll say right-clicking is blocked. But this is basically a test to see if you're able to do some research. So bugged LDevs. Well, yeah, kind of LDevs. I guess they weren't thinking about Firefox. Strange. Okay, so what it wants you to do is it wants you to use the keyboard shortcut, which is which Volko pointed out previously was Control-U. So once again, we see that the password for this level is located within the HTTP source. So we can copy this and we can use it to access the next level. Firefox outsmarted the system. Well, the devs weren't thinking about didn't think of everything, which is okay. Okay, so we're gonna go to the next level of the game, which is Natas 2. So Natas 2, of course, we need to provide a username, which is the name of the level, and we have to provide a password. So we can just paste in the password over there and sign in. Okay, and in this level here, it says there is nothing on this page. Me need to run to party, Saihat. Okay, well, have a lot of fun partying it up. I'll catch you on your next stream. But yeah, if anybody is interested in sticking around to learn a little bit about web app security, feel free to stick around for a little bit. I'll complete the next few levels of this game, and then we might wrap it up. Okay, so it says there is nothing on this page, but what do? We need to access the HTTP source. Poor Eye says, check inspect element again. There is networking because nothing's probably there. Okay, so what we can do is we could view the page source, and what we need to do is we need to identify anything that might be suspicious inside the page source. So, so it says here in the comment that the stuff in the header has nothing to do with the level, so we can safely ignore everything up until about here. And it says there is nothing on this page except that there is a source over here. So the source leads to files/pixel.png, right? So we can access this file, and it is true to its name. It's a single pixel. So it's an image that's composed of a single pixel. But what else is suspicious about the contents of this? Sorry, not the contents of this, but what is suspicious about this link right here? Can anybody identify this? Poor Eye says, "Who has a single pixel image?" Well, it's a game, so what can anybody identify? It's in a directory. Volko did has done security testing in the past, so he probably knows what's up. So it's in a directory. It's in this directory called Files. So inside of the web page, we can go to the Files directory by just typing it in the address bar. So files might have something else. That's correct. Okay, so it says index of files. So this this particular web app has directory indexing enabled, which means that we're able to navigate directly to these directories, and it's going to show us the contents of the directory to basically anybody who navigates the directory directly. So there's the pixel.png file that we previously looked at, and there's the users.txt file, which is kind of suspicious. So we can access the file, and then it has a number of usernames and passwords over here, including the password to Natas 3, which is the next level, which is this right here. So that's the password to the next level. LW Killer says, could we access other files within the files directory? Yes, and we just I'm sorry I read that comment a little bit late. So that is the whoops. Let me go back to Natas. So the next level is Natas 3. LDevs keeping user database public. Well, yeah, I guess so. Should we check the other usernames? Oh, you know what? I've never considered that before. but I'm going to go to Natas level 3 first. Let's go back. So Natas level 2. So there's nothing on this page, but we can go to the files directory. So we have, okay, so I'm going to copy these and paste them into chat. So anybody who wants to try can go ahead and try. But remember that you have to separate, you have to omit the colon that separates the username and the password. Okay, so in here, let's try Alice and then this particular password. So I have a suspicion, a sneaking suspicion that it's not necessarily going to work. Whoops, let me try pasting that again. Okay, so it doesn't let us in. So we should use the Natas 3 password. So I'm going to copy that again. And then Natas 3. Then the password's right here. Sign in. Okay, and once again it says there is nothing on this page. But what we're going to do is we're going to view the page source, like good little game players. And inside of the HTTP source, we have this comment right here. So no more information leaks. Not even Google will find it this time. So does anybody know what this could be potentially referencing? So this is referencing a specific technology. Okay, so Poor Eyes says check cookie. Okay, we could check the cookie that we got for this particular level, but it's talking about information leaks and Google being able to find it. So does anybody know what technology that they're talking about? So Blizzard WQ says dorks. Okay, so what they're referencing right here is a particular technology called search engine spidering or search engine crawling, and there's a particular file that's associated with what is it? What is it called? With making sure that the search engine robots can only see what you want them to see, which is called robots.txt. Poor Eyes is completely correct. So there is a robots.txt file on this particular web app, and the robots.txt file is used to limit what the search engine robots are able to see. So if you specify inside the robots.txt file that you're not allowed to index a certain page, then it's not going to index the page and show it in the search results. So inside of the robots.txt file over here, we see disallow secret. So what does this mean? This means that when the search engine robots are crawling this page, this particular web app, they're not allowed to go inside of this directory. But it also means that if you're a bad guy hacker guy, you can go directly to this folder right here, which could have some sensitive information in it. So it says, Poor Eyes says bad guy hacker guy W. That's correct. Okay, so we can go to this secret directory right here, and oh, that's really big. Okay, and once again, we see the users.txt file. So inside the users.txt file is the password for Natas level 4. So let me copy that to chat. Okay, so we're going to use this password to access Natas level 4. And the username is Natas4, and the password is the password we just got. Sign in. So LW Killer says, so basically we gain access to this piece of information specifically because they put in measures to prevent us from accessing it. Well, the robots.txt file is designed so that search engines don't index sensitive parts of websites. But if you're able to access the robots.txt file yourself, then you could find some sensitive directories inside of a web app. You know, if we go to google.com, we can actually go to the robots.txt file inside of google.com. And there's a bunch of different directories that are allowed and disallowed for search engine robots to crawl through. So this is a legitimate web app application like tool, but it can be used in a malicious manner as well. Okay, so it says here, access disallowed. You are visiting from blank, while authorized users should only come from HTTP natas5.nataslabs.overthewire.org. Volko says, yes, yeah, the robots.txt is not an access control mechanism. It's just a suggestion to search engines, similar to do not track headers. Yeah, so it's a legitimate function, but what we can do is we can take advantage of it. So Porized says, spoof origin to Natas 5. So that is exactly what we need to do, but we can do so in a couple of different ways. So the first thing we can do is we can use the curl program to access the page instead of using our web browser. So let me grab my terminal and make it nice and big for everybody to see. So we can use the curl command. So it's going to be, so actually, if we didn't know how to use the curl command, we could ask ChatGPT, and using curl, how do we access a web page with a specific refer header, and also log in with basic auth. Okay, so here it says that this is the target command we want to use with curl. So does everybody here know how to use their terminal, whether they're using Windows or if they're using Linux? So there's the example command, and this is on the web page here. It says what the correct refer header should be. So I'm going to edit this. So inside of curl, you have to include your username and password. So it's Natas4, and then the password is the password I provided inside of the chat, and I'm pasted in. So the refer is going to be this right here. What we can do is we can go to the web page and copy this exactly. I'm using Windows terminal as an MS-DOS. Well, so what you can do is you can go down to the search bar and type in CMD, and you're going to see a program called command prompt. And so you click on that, and that's going to give you your Windows terminal. Okay, so go back to the terminal, and then so refer is going to be, refer is going to be whatever we paste in right here. So it's going to be natas5.nataslabs.overthewire.org, and then we're going to try to access Natas4. So it's HTTP natas4.natas.labs.overthewire.org. Okay, so I'm going to copy this for everybody in chat, just in case you don't feel like typing all that in. Volko says, refer is misspelled even in the HTTP specification, though I no one asked. Well, it's something I like to point out to everybody when I'm teaching this stuff. But yeah, it's misspelled. I guess because the person forgot to spell it correctly. Not sure. but we can run this command right here, and it says action disallowed. Okay, so I messed up somewhere in my. So what I like to do when I run curl is I want to give it the -V flag right here for very verbose. So I'm not sure. Oh wait, the header. I forgot to put refer in there. Okay. I think that's supposed to be it. Yeah, okay. Okay, then I'm going to run it again. Okay, so right here, we see the HTTP request right here, and this is the request portion right here, and then this is the response. Oh, sorry, no, this part right here is the beginning of the response, and you see that inside of the content, we see that access granted. The password for Natas5 is this right here. So I'll copy that and I'll give that to chat for everybody to try. Sorry, if you wanted to get the full curl command right here, the one that works, I'll paste that in chat as well. Okay, so which means we can access the next level. So the next level is Natas5. So has anybody here done the Natas over the wire game before? Just curious. Okay, so the username is Natas4, Natas5. The password is, oh, let me copy the password. Hold on. The password is this. No, well, I'm glad to show you guys something new. Okay, so the password is this. Sign in. Okay, so access disallowed. You are not logged in. Okay, so this is another puzzle right here where we're trying to deal with HTTP headers and HTTP cookies. Blizzard WQ says, did Bandit. Well, I'm glad to hear that you've done other security CTF games. Volko says, no, I think it's newer. I haven't done over the wire in 10 years. Poor Eyes says, check login cookie flag. Okay, so we could certainly try that. So inside of your browsers, you can usually click on the extra options button over here. It's called a hamburger button, I think. And inside, you'll usually see some sort of settings or tools. Over here, you can go to more tools, and then you can go over to web developer tools right here. So inside of web developer tools, authentication required. I don't need to do that. Okay, so inside of the web developer tools, there's probably going to be a tab called storage. So what you need to do is click on storage, and then there's going to be the cookies for each one of the websites. So there's one for this particular web page right here. Click on that, and then I don't know if I can make this bigger. I can't make this bigger. Okay, but there's going to be a cookie called logged in, and the value is going to be set to 0. Poor Eyes says change the value to 1. So that is exactly what we do. So when the value is set to 0, it's set to false because we're talking about booleans. 0 stands for false and 1 stands for true. So we can set the value of the cookie logged in to 1, which is true. And then we can press enter, and then we can reload the page. So it's Control R, or I don't know what the keyboard shortcut is on Chrome, but. And then after you reload the page, the new value of the cookie is recognized, and then we get the password for the next level. So I'm going to copy that and paste that in chat. Okay, so that was Natas level 5. All right, next is Natas level 6. I'm going to replay my music. because I like having it in the background. Okay, so Natas level 6 is next. And the username is Natas6. So I hope you guys are having fun solving these challenges. And I hope you're not too bored because you already know this stuff. So sign in. Okay, so this is the first challenge over here where we're given some source code. I don't know how many of the people in chat are developers or know anything about web dev languages, stuff like JavaScript or PHP. But it says over here input secret. So we can put in something and submit the query, and it says wrong secret. So there's also this button right here, which lets us see the source code for this particular page. So we're going to put this in a new tab. So what we're dealing with is some PHP code right here. So if you see this this PHP code right here, what clue stands out to you, which is something you could potentially look at to figure out what we're trying to see, which secret we're supposed to input. Okay, Poor Eyes says, check the import. Okay, so by import we mean the include right here. So much like Python, so in Python you have to use the word import, but in PHP you use the word include. So in this case it lets us, so include is going to let us use code from a different file, and in this case it is includes/secret.inc. So this is the directory right here. I think it's a relative directory, and then this is the file right here. So we can copy this, and then we can go back to the original page here, and we can paste this in. So when we go to this directory right here, secret inc, we don't see anything. But I think if we view the page source, then we get the answer. So this is a variable right here, which is secret, and it is set to this. So we can copy this and we can feed this to the web app on the original web page. So input secret, it is the thing we got from the other file. I'm going to check real quick to see if we can see any other files in the includes directory. Okay, so this is the right way to do it. You don't have permission to access this resource. Okay, so in the original web page, we submit the secret, submit query, and then it says access granted. The password for Natas 7 is this thing right here. Copy that. Volko says, looks like someone would yell. Looks like something someone would yell while dying in a video game. Yeah, it kind of does. What was it? What was it again? Hold on, I'm gonna try to clean up my tabs a little bit. Okay. All right. So sorry about that. You know what? I'm gonna go in and change my bot after this stream because it's a bit too restrictive. All right. So the next level. So we're going to Natas level 7. Username is Natas 7 and password is this thing. Okay, so we have two pages over here. Right here, there's a home and an about page. If we click on the home page, and then we click on the about page, do you see anything immediately suspicious when we're clicking around on here? So we can also look at the page source in this level. So Poor Eyes says URL link change. Okay, that's the correct thing we're supposed to look at. Hold on. So there's a URL link change right here. So there's a parameter. So the parameter here changes. It changes from page equals home to page equals about. So does anybody know what could potentially be abused here? So Poraz says, bruh, this is like level 1 if they telling you that in source. Okay. But yeah, inside the source here it says password for web user Natas 8 is in this directory right here. So does anybody know what kind of web app vulnerability we're looking at? Okay, Blizzard WQ says LFI. Blizzard WQ, I have a sneaking suspicion that you are a cybersecurity student or a cybersecurity professional. Is one of those correct? Porai says she. I don't know the name. The name. Okay, so we're talking about LFI, which is local file inclusion. So this means that the web app is using local files, is accessing local files, and is able to access arbitrary local files on the web server. And oh, Blizzard WQ, I'm glad to hear that there's a fellow security person in the stream. Okay, so we're talking about local file inclusion, which means that the web app is able to read arbitrary files in the file system. So how we would test for that is we would go up to the URL over here, and because we know that this web app is running on a Linux system, we would try to escape from the current directory, and we escape from the current directory by giving a bunch of //slashes. So //////, and this lets us navigate to the top of the web server file system, and then we can check for common Linux files to test if we're able to execute on this local file inclusion. So a common file that I like to check when I'm checking for local file inclusion is the etc password file in the Linux system. So I'm going to copy this path for everybody in the chat. You guys go ahead and try using this. Okay, it doesn't. The chat app doesn't like me putting that in the chat. But go ahead and go up to the address bar, page equals // maybe 7 times, and then etc. and then password, misspelled like this. So when we try to access this, it's going to give us the contents of this file that is on the web server. So this particular file in Linux is all of the users on the system. So it's not only legitimate users, but it's also user accounts that are associated with services. So there's root, of course, and then there's a bunch of other services that have their own accounts. And there's a user account for each one of these levels over here. So Natas 1 to Natas 30 something. So now that we know that we can access arbitrary files on the file system, we can access the file that contains the flag. And we know which file contains the flag, but it's inside because it's inside the hint over here. So the password for web user Natas 8 is in this location right here. So you can copy this, then go back to your page with the URL, and you can paste this in. Just make sure that all of your grammar is correct over here. So when you access this, what we're doing in this level is using the local file inclusion vulnerability to access arbitrary files on the web server. And so we access the password file for Natas 8, and it is this right here. Okay, so LW Killer says, doesn't the page source tell us to go to etc Natas webpass / Natas 8? Does the one that you showed with the etc. password allow you to skip levels? No, it doesn't allow you to skip levels because the web server is running with the permissions of a particular user, and that user is only able to access certain files in the file system. So if you try to access Natas level 9 password, it's not going to go through. And if you try to access, but what you can do is you can access Natas level 8. So you can access Natas level 8 and you can access Natas level 7, I think. Yeah, but you're not able to access any other ones. Wired Me IRL. Hey, glad to see you back. Hey, I can't study right now because I'm studying for another exam, but I wish I could see more free hacking courses. Is ChatGPT that good for looking if codes are okay? And what subjectives were taught in this lesson? Well, you can go to my YouTube page after the stream is over, and because all of the VODs for my live streams are saved to my YouTube channel. But yeah, I wish you luck in your next exam. Okay, so let's go to the next level then. So I'm going to clean up this. I'm going to clean up this address right here, and I'm going to Natas level 8. Okay, so the username is Natas 8, and the password is what we got in the last level. Sign in. Okay, and the next level here is another one of these view source code challenges. So we're going to test this, and it says wrong secret, input secret. What we need to do is we need to take a look at the source code again. So we can take a look at the source code. Hold on. Okay. So we have here a function that has a variable called encoded secret, which is this hex code right here. And then we have a function called encode secret that takes in a variable called secret, and that returns binary to hex, and then string reverse, and then base 64 encode, and it does all of this to the secret. But it's basically looking for the value of encoded secret before it is encoded. Okay, so Poor Eye says run the code. Run the code. Okay. So what we can do is we can copy this code and we can go to some web app that does just that. So I think there's one called PHP Online, PHP Sandbox. Okay. So I'll paste this for everybody over here. So because this is PHP code, we can put it into this PHP sandbox right here. Hold on. Okay. Porai says, how many levels of Natas are there? So I think there are somewhere in the neighborhood of like 38 levels for Natas. There are a bunch of other games on the Over the Wire website, but the one that teaches web app security is Natas, and there's like 30 some odd levels for that. Okay, so it says encoded secret over here. What we need to do in this level is, what do you think we need to do to solve this level? Just any brainstorms? So we've got this PHP code that tells us just print out the encoded secret. But this is the encoded secret. But the function encode secret doesn't take the encoded secret, it takes secret. So what we need to do is, the function, just print out the, okay, so if we print out I think what is the function to print out inside of PHP? It's echo, right? Echo encoded. So this isn't going to work exactly how we like. So we can try this. In fact, what we need to do is we need to get rid of this. I think we need to get rid of this part of the code. Undo what the function does. Yeah, what he said. Okay. All right, so what we need to do is, so first of all, we can get rid of this if statement right here. And does that mess up? I hate dealing with brackets. Okay, we can get rid of this bracket too. Okay, so what we need to do is we need to reverse this. And so we know that there are, so this encoded, so encoded secret over here, we're going to change this function to decode secret. So decode secret that takes in encoded secret. Okay, so what it does is that it does bin to hex. So it does base64 decode first, and then it does string reverse, and then it does bin to hex. So if we reverse it, what are the order of operations here? So if we reverse the order of operations, then base64 encode, not encode, but decode is the last thing. And then not bin to hex, but hex to bin is the first one. So the first thing is hex to bin. And then string rev is in the middle, so we just need to keep that as it is. And the next last thing is base64 encode. Wait, how do you spell that? Hold on. Base64, you need an underscore here, okay. So it's base64 decode, it's hex to bin, and then string reverse, and then base64 decode. Because the original order was bin to hex, and then string reverse, and then base64 encode. So we're taking these things, we're reversing the order, and we're reversing what's happening to the information. And we're going to be running decoded secret instead of encoded secret over here. All right, so Blizzard WQ says base64 decode first. Right. So it's hexadecimal, which is this, to binary first, and then reverse the string, and then decode from base64, and we should get the original string. So let's try running this. Decoded secret. Oh, okay. Hold on. Decode secret, encoded secret. Did I spell something wrong? Oh, this should be encoded secret right here. You have an extra D. Where's my X? Okay. Encode secret. Okay, so encoded secret. Okay, let me try running this again. Okay, so after we run that, we run all of this. This is the result right here. So this is the original secret before it was encoded. So I'll copy this to the chat. Nathan Chan says, way to go, Kevin. Well, Thank you. Well, I've done this before. I actually teach this in my classes. But doing some coding on the fly can sometimes be kind of stressful. Okay, so now that we have the secret that we're supposed to put into the web app, we can input the secret and submit the query. Poor Eye says, bro's actually a teacher. Well, that's what I'm trying to do. I'm trying to teach people how to do cybersecurity basics from my Twitch and YouTube channel. Okay, so the password for Natas9 is this. I'll paste this in chat. Okay, so we might do to Natas10, and then we'll call it a stream. But thank you to everybody who is here and is willing to go through these levels with us all. We're going to Natas level 9 now. Poor Eyes is now a HackerFrog. Well, welcome, Poor Eyes. Glad to have you here. Natas9, and then password, paste it in, sign in. Did I copy my password incorrectly? Hold on, let me copy it again. Okay, so find words containing something something. Search. Okay, so let me make this bigger. So inside of the search field right here, we're just going to give it a test, and then we're going to hit search. So right here in the output, we see that we received a lot of different words right here that contain the word test. So it's probably referencing some sort of file that has a bunch of words in it. Okay, LW Killer says copying almost always adds a space at the end. Yeah, it's something that I need to be aware of. Okay, so it looks like this particular web app is searching through some sort of file, and we actually have another view source code link right here, so we can put this in a new tab. All right, so let's take a look at this code. So this is more PHP code. So you can tell something is PHP code because it uses this these particular brackets right here. So it's a bracket question mark and then question mark bracket. But this is what the function does. So there's a variable called key, which is an empty string. So if array exists, so if this particular key variable is not empty, then it's going to request, and the key is equal to the request. And if the key is not empty, then it's going to run this function right through, which is pass through. And what do you think is happening inside of this command right here, the pass through one? So Poor Eye says checking dictionary.txt for the value. Okay, that is correct. So this so the pass-through function is a special PHP function. Blizzard WQ says executes commands on system. Okay, so if this particular web app is using the pass-through function and running commands on the web server using Linux commands. So grep is a Linux command, and it's going to look through the dictionary.txt file for particular strings, the ones that we provide to the web app. So what particular vulnerability could we exploit to try to get the password for this level? So Nathan Chan says, but how do we exploit this? So there's a particular let me hear from chat to see if they know the answer first. So Poor Eye says we can use pass-through to execute other commands. That's absolutely correct. So we can use the pass-through function to run other commands. So right now it's running grep, and then grep right now on dictionary.txt, but we can have it Yes, Blizzard WQ says chain the commands. We can do that. So LW Killer says so we can somehow gain access to dictionary.txt. So we're not trying to access dictionary.txt. We know from, let me look at the over the wire. So on this page, it says, your job is to somehow obtain the next password and level up. All passwords are stored in the etc. Natas pass web directory right here. So for example, Natas web pass Natas 5 is only readable by Natas 4 and Natas 5. What we need to do is we need to access the Natas web pass file for Natas 10. So it's going to be in this directory right here, but replace Natas 5 with Natas 10. So inside of the app, what kind of command do we want to send to the web app to let us see the password for Natas 10? So LW Killer, sorry, Blizzard WQ said chain commands. We can definitely chain the commands. And Poor Eye says grep the other pass file. Okay, yeah, we can absolutely grep that file. So what we can do is we can, so inside of here, we can end the command. So we can end the grep command, and then we can send another command after this. But Poor Eye says we can also grep the other password file. And we can absolutely do that too. Or we could also just use the regular cat command to read the file as well. So in order to do that, we would just supply the semicolon here to end the command, and then cat, and then whatever that directory was. Copy this, go back. So we're looking for, so Poor Eye says, is this similar to SQL injection? Yeah, well, this is what is called OS command injection, and it is similar to SQL injection in that we're doing injection to access another system. So I'm going to paste the command in the chat for you guys to try out yourself. So over here, what we need to do at the very end of this command is to comment out the rest of the previous command, which we can do with the hash right here. So just whatever I put in the chat, just to put this hash symbol at the end of it, and this should allow you to read the password for Natas 10. So click on search, and this is the output right here. So that's the password for the next level. Okay, so we'll do one more level before we call it a stream. But in this case, let's navigate. So you can also see that inside of the URL right here, that everything that we supplied to was recorded as a URL parameter. So let's see. Poor Eyes says shy at W stream. Well, thank you very much, Poor Eyes. Nathan Chan says awesome. Thank you very much, Nathan. And LW Killer says it seems to work without the hash. You just get the whole directory, whole dictionary printed as well. Yeah. But yeah, we like to try to be concise whenever we can. All right. So Natas level 10. Last one for tonight. Username is Natas10, and password is this thing. Okay, so this is a repeat of the previous level, but it says here, for security reasons, we now filter on certain characters. Okay, so we can give the exact command that we used for the last level. What was that command? This. So we can try to read Natas 11 with this command right here. but when we try to do so, it says input contains an illegal character. Okay, so we can go ahead and read the source code in the new tab. So let's take a look at what's going on here. Polarize says, "She, Dev's getting smarter." Well, that's kind of the point. All right. So it's the exact same code as the last app, except that if so it's using this this preg match function right here that includes these different characters. In this case, it's going to be the semicolon, the pipe, and the and character right here, which means we can't necessarily use any of these commands in our command injection. So what we're going to need to do is we're going to need to do something called filter bypass. So this is a filter right here, and we need to find a way to bypass the filter in order to access the password for the next level. So can anybody tell me exactly what we should do? What we should do to get the password from the next level? I'm going to tell you that that the contents of this line right here are important. Okay, Poras says, I don't know, can we still execute without the semicolon? Yeah, we can still execute. You can still read the password file without the semicolon. But the question is, how do we do it? So Blizzard WQ says try backticks. That's an interesting theory. How do we use the backticks? Porai says, can we add on to the current grep? Yeah, we can add on to the current grep. So the way the grep command works is that you can supply multiple files to the grep command. So that's an interesting theory, Porai. So what should we do if we can add on to the current grep? So Blizzard WQ, using backticks might work in this particular scenario, but like, how would we? What command would we exactly use to use the backticks? So Porai says possibly do the ... slash. I thought slash is restricted. So slash is not restricted. So the slashes over here are just defining the this particular what is it called, array. So the array contents are this, and these brackets right here are what contains the contents of the array. Porai says slash isn't actually restricted. That's to delimit the regular expression. That's correct. Porai says hell yeah, just ... slash all the way to the file then. Yeah, well, okay. But we don't need to ... slash. We just need to reference the file directly. So we know that the file is this right here. So this is the exact location of the file. So what do? Well, we can't use the semicolon, and we can't use the cat command in this case, because we're trying to use the grep command. Porai says haven't used grep all that much, so I don't know. So grep can take multiple file names as arguments, Volko says. So that's correct. So maybe we just put in the file name, yeah, the path. Okay, that's correct. So let's take a look at the code right here. So it says grep I key and then dictionary.txt. So we can grep I key, so whatever we're looking for, and then we can specify the file right here. So it's dictionary.txt, but we're also adding the password file for Natas 11. But we also need to add some sort of thing that we're searching for in order to use grep. So space file path. Yes, that's right. Okay, so here we can do Natas 11, this file right here, but we also need to supply a search term. So we can supply the search term A. So it's the letter A. We're searching for the letter A, and if the letter A is included in this file, it's going to print it out. So what we're checking for is if there's the letter A inside this file, and if it is, it's going to tell us the full string of the file. So I'm just going to copy this to chat for you guys to try out. So we're going to search. So here's what happens. So we get all the words in the dictionary.txt file that have an A in it, which is a lot. But we also get the contents of the Natas 11 password file, which has an A in it. So Poor Eyes asks, if there isn't an A in there, we just try all the other letters. That's correct. So if there's no A, we can try B or like a bunch of numbers and letters, and eventually we're gonna get something that has the password that's in the password, right? So copy this, and that's the password for the next level. Okay, well it's been a lot of fun doing all of these Natas CTF levels with you guys. Poor Eyes says LDevs filter bypass W. Yeah, that's correct. So before I go, and before I end stream, I'm going to do some shameless self-promotion. So I've got a YouTube channel. It's youtube.com/@theshyhat. And if you guys want to learn some cybersecurity stuff, I've got a bunch of videos on here. And I've got a little course which has all the stuff that we've been learning today, as well as web app hacking. I've got some Python programming here. I've got some Linux OS operations, how to use Linux. So LW Killer says it seems like it doesn't check for uppercase or lowercase. So yeah, it's not. So this particular grep search doesn't distinguish between uppercase and lowercase. So yeah, that's my channel. I'll just leave the link in the chat in case y'all wanted to take a look. Volko says good stream. TTYL all. Well, thank you very much for coming and staying, everybody. Yeah, I was actually really confused when I got the raid from Snowcones. But I'm glad you all came by, and I'm glad you all had some fun learning about cybersecurity with us. Let me see if there's anybody on Twitch that I can send you all to. Oh, I know. All right, yeah. Thanks for coming by, everybody. If you're ever bored and you see me online, you can always come and check it out. But yeah, I will see you next time. I hope everybody has fun with the chickens in the next channel. Catch y'all later. Anonymous just subscribed. Thank you very much for your subscription, Anonymous, on the YouTube. Take care, and we'll catch you next time.